Hello, my name is Christina Tran. Today we'll be doing a problem from Chapter 20, Electrochemistry, about solving for Ecell, K, and free energy at 25 degrees Celsius when given the electrochemical cell. The problem 20.8 reads, what is Ecell, K, and free energy for the following electrochemical cell operate at 25 degrees Celsius? The problem also gives you a cell diagram of a copper solid oxidizing to copper plus 2 and zinc plus 2 reduced to zinc solid. To approach this problem, first identify what's being asked in the problem. In this case, we are solving for Ecells, K, and free energy or delta G's. Remember to use the correct equation to solve for this variable. Remember that your temperature should be in Kelvin, then carefully select the E0 cells from the standard reduction potential charge for the half reaction. Make sure to check your correct units in the equation and answer. And lastly, remember to check your significant figure of the final answer. Here are the equations that we'll be using to solve this problem. To calculate E0 cells, we'll be using E0 cells equals E0 cathode minus E0 anode. To calculate K, we'll be using E cells equals E0 cells minus 0.0592 over the number of mole electrons being transferred multiplied to logs of K. And to calculate the E cells at any given time, we'll be using the Nernst equation, which reads E cells equals E0 cells minus 0.0592 over the number of moles electron being transferred multiplied to 10 base logs of products over reactant. To calculate the free energy or delta G, we'll be using delta G equals negative RT to natural logs of K when the R is a universal gas constant of 8.314 joules per K moles, and temperature will be converted from Celsius to 298 Kelvin. We first begin with writing out the balance reactions from the electrochemical cells, then we'll find the half reactions for copper and zinc. Since copper is being oxidized from copper solid to copper plus 2, it is an oxidation reaction, leaving it as an anode. And zinc is being reduced from zinc plus 2 to zinc solid. It is a reduction reaction, leaving it as a cathode. Next, after finding the reduction potential for anode and cathode, we will plug it into the E0 cells calculation. And since this is a subtraction process, the answer will be in 2 decimal points, leaving the final answer of E0 cells equals negative 1.10 volts. Using the Nernst equation, we will calculate the E cell value. We also use the E0 cells value that we just calculated and the concentration of product and reactant in molar given in the problem. After plugging in all the value and calculating the E cell value that we got, after rounding it up to 3 significant figure, we have the E cells equals negative 1.10 volt, the same value as E0 cells of negative 1.10 volt as well. Now we proceed to calculate for K using the E cells and E0 cells value that we just calculated. After adding 1.10 volt to both sides and dividing by 0.0592 over 2 moles of electron to both sides as well, we have log K equals negative 0.2218. And to solve for K and to undo the 10 log base, we will take 10 to the power of. Our final answer is K equals 0.600 in 3 significant figure. Now we calculate the free energy or delta G using the K value and using the temperature in Kelvin. After converting 25 degrees Celsius to 298 Kelvin, we plug into the equation. Our final answer is in joules. However, delta G is often written in kilojoules, so our final answer will be 1.27 kilojoules with 3 significant figure. To recap, we have successfully solved for the 3 variables being asked in the problem. To double check if our answer makes sense, we will use the relationship between K, E0 cells, and delta G0 cells value of the electrochemical reaction chart. Since our E0 cell is negative and our delta G value is positive, this means that this reaction is not spontaneous. Looking at the K value, it is less than 1, meaning that reaction favors the formation of reactants or in reverse direction. Overall, our answer makes sense. In summaries, when solving problems similar like this, remember to read the question carefully. Make sure to identify the variable that's being asked in the problem, such as for E cells, K, and free energy. Then use the correct equation to solve for this variable. Also, carefully select the E0 value for the standard reduction potential for each half reaction. Remember to double-check your units in the equation and answer, and finally, always double-check your significant figure of the final answer. Thank you so much for watching. Have a great day.